you know, they're gonna whip through this really quick. But even if you had another teacher, you just gotta remember what we're doing. Okay, this is vertex form. It got cut off by the copy machine. So vertex form, y equal a, quantity x minus h squared plus k. Yeah, you guys remember that? Okay, your vertex is hk, right? So yeah, we're just gonna go through that. Okay, your a value. So we're looking at this one. What's your a value? 0.5, right? Remember, that's your A, so A, right, your placement. Okay, is that A value positive or negative? It's positive, so then you write positive here. And so because the value is positive, is the parabola, or the quadratic, is it concave up or concave down? Up, right? So it's like a smiley face. Remember, if this is positive, it's going up, right? So this is concave. And so some of my students got used to just drawing that, and I would give them just credit for it. Yeah. If it's negative, it's concave down. So that's dependent on your A value, right? Okay. Maximum point, we'll come back to that. Because normally we would graph it, and then I would come back to it for the visual, so you guys like buy into it. Yeah, because I know there's quite a few in here that had me last year. All right, axes of symmetry, same thing. Okay, so let's jump to HK. Okay, what's the value of H? Yeah. Okay, if you guys remember, on the H, what you see, you go opposite H and you follow K visually. So even though you see x minus 3, it's really x minus that h value. So really it's x minus, and the h value is positive 3, right? It goes x minus h. So that's why you go opposite h, follow k. So when you see a negative 3, it's really a positive 3. Yeah? Okay. K value, you follow it because it's plus k. So whatever the number is, that's what you're looking at. That's the value. So what's k? 7. Okay, so then my vertex is always hk, right? So it's just 3, 7. Okay, we'll do the horizontal, vertical shift, maximum value, maximum point. We'll come back to that after we graph it. Okay, so if I go to the table, I always told my students, but to each his own, you always put your HK, your vertex is kind of in the middle slot, so 3, 7, and then we're going to pick 2 numbers up and then 2 numbers down so that you guys get the symmetry. Right? You guys remember that equal distance to the vertex? That's how you just kind of graph it, so you get it in pairs. Okay? All right, so if you think of a number line, let me get, this is good. A little bit of graph paper here. Okay, if you think of a number line, all right, here's 3. Okay, what's one number to the left and to the right of 3? 2 and 4. Okay, and it doesn't matter if you go 2, 4 or 4, 2. Okay, so that means those 2 y values, the output, are going to be the same, right? They're equal because they're equal distant from the vertex, right? Remember, there's symmetry with parabolas. Okay, what's 2 units to the left and 2 units to the right of 3? 1 and 5. And so there's my 1 and 5. And so if you do that, you're going to get your equal y values. And it's less work. You can do whatever you want. You can pick whatever values, but remember, you need at least 5 points for a quadratic. You got to give me that curve, okay, the bowl. All right, so it's up to you. You can solve it by hand, or if you know a calculator and you're comfortable with it, let's plug in the 1 minus 3 squared plus 7. Okay, one beginning mistake. If it's x minus 3, notice I put 1 minus 3. I know we said the h value was positive 3. Sometimes students will then change that to a positive 3 because they'll be like, oh, but you said the h value. Yeah, no. The equation is 0.5 x minus 3 quantity squared plus 7. I'm strictly substituting the 1 for that x. Everything else stays unchanged. Yeah? Okay, hit equal. Are you guys okay? Hit equal, and I get 9. And so that means 1, 9 is the same as 5, 9, because they are both equally distant from this 3. If this is your 3 value, 1 and 5 are both 2 units to the left, 2 units to the right. They're going to have the same output value. And so then you go and replace the 1 to the 2. Right, so I substitute 2, and I get 7.5. And so 7.5, 7.5, and now you can plot the points and get your parabola. Do you guys kind of remember this? Yeah. A little bit? Okay, all right, so now you just plot the points. So 1, 9, wait, there's 1. Okay. 2, 7.5. 3, 7. And so it's not a v, it's not an absolute value function, it's a parabola. Bless you. It's a parabola, and so that's what you get. Yeah, this is a year ago, like in a few weeks you guys started this. Keep going? Yeah, okay. All right, so now if we come back to this axes of symmetry, max min value, description of the shifts, yeah, the point. Okay, axes of symmetry, AOS, it is always your H value. So if your H value is 3, it's X equals 3. It's always the same as your H. We're going to get a lot of repetition here. Okay, your HK just gets repeated. All right, X equal 3 is a vertical line. That is, it goes through the vertex, and this is your axis of symmetry, X equals 3. And because it shows the symmetry of that, if they're equally distant, they have the same Y value. And so that's why this is 1 to the left, 1 to the right, and that's why they were both 7.5. 2 units to the left, 2 units to the right, and that's why you have that 9. So that equidistant, that's your axis of symmetry. It cuts it right in half. Okay, that's your axis of symmetry. What's your max min value, max min point? Okay, because it is concave up, is it a max or a min point? Min, right. Okay, so it's going to be the min point, and that point is the vertex point. It's the exact same point. Because what it is if I dot it here, it's your lowest point. So if it's concave up, it's your lowest point. If you're concave down, it's your highest point. It's the peak. Okay. So here it's a minimum point, and that's just here. That's just that 3, 7. It's that lowest point. That's it. Okay. Max min value, that's your K value. So if the K is 7, that is the K. Oh, and then it's a min value. And that's your K, which is just 7. It's not Y equals 7, it's just 7. And what that means is when you look at your parabola, your quadratic, okay, my point was really fat, but this is the lowest, because when we talk about domain and range, that's the lowest for the range. That's why it's talking about that. Do you guys remember domain and range? You probably did a little bit of it. Yeah, you might have done, yeah. And then you guys kind of left it. Okay, horizontal shift, vertical shift. Okay, so this is your parabola, and this is your origin. How do I describe the horizontal shift and vertical shift from the origin? This is where the vertex is, right? The parent graph would have it at 0, 0. It's here at 3, 7. So what's my horizontal shift, right or left? Right? How many units? 3. 3 right. It's okay if you guys get it wrong. You haven't done this for like 8 months. And then what's the vertical shift? So I go 3 right and up what? 7. That's it. 7 up, 3 right. That's it. Not bad, right? Okay, so you'll give this one a go, and then I'll show you guys the answers. I'll solve it. But and then tomorrow we'll do the inverse, and then we'll graph it. We'll go back to your worksheet. So this sheet is worth like several assignments. So that's what I'm saying. You don't want to fall behind with it because we just did linear. So that's an assignment that will go into the grade book. Then we're going to look at these, although they're a little easier, but we'll start off easy. And then we'll go to your square root function. So that's why don't get rid of this just because you finish the linear ones. It's going to keep going. Okay, so let me shut this off. It'll disappear, but it'll come back up.